Today we're going to continue graphing equations that are in standard form, but this time we're actually going to look at application problems. So remember when we're doing this that we're going to start by finding the axis of symmetry and then the vertex and then finding two other points. Let's look at the first problem. Okay, the height in feet of a basketball that is thrown can be modeled by f of x equals negative 16x squared plus 32x, where x is the time in seconds after it's thrown. We need to graph this function. So we are going to go ahead and start out by labeling our a, b, and c in this function. A is in front of my x squared, b is in front of my x, and notice there's nothing here for c, so we actually don't have to worry about that. Just to review, to find the axis of symmetry, we're going to use the formula the opposite of b over 2a. So when I plug those values in, I'm going to change the sign for my 32 to a negative, and I'm going to plug in negative 16 in the bottom. And we're going to simplify. So 2 times negative 16 gives me negative 32. And when I divide negative 32 by negative 32, I get 1 for an answer. Okay, this is the first part of my vertex on my graph. Okay, so this is my axis of symmetry here. Okay, we're going to go ahead and plug that into the equation and figure out what we get for our y value. So negative 16 times 1 squared plus 32 times 1 gives me 16. So my vertex is at 1, 16. Okay, I'm going to go over 1 or 2 to the right. So I'm going to do 2 and 3. And I'm going to plug those in to find my y value so I can get 2 more points. So if I plug in 2, negative 16 times 2 squared plus 32 times 2 gives me 0. When I plug in 3, negative 16 times 3 squared plus 32 times 3, I get negative 48. Okay, and that's actually not going to fit in my graph. So we're going to go ahead and put our 2, 0 here. Remember, we need to reflect this to the other side as well. Okay, so what I have here is that my graph starts at 0, and I apologize, it's not going to be very good on here. Goes up, and then comes back down. And we're going to try that again. Okay, so we start at 0. We're going to rise up until we get to this vertex, and then we're going to drop back down to the 0 here. Okay, so in this situation, keep in mind that this is really my ground here. So my ground is at 0. Notice the ball, I didn't put arrows here because the ball can't go below the ground on either side. Okay, we're actually going to answer some questions about this graph and the equation in the situation. So let's look at those questions. Maximum height, if you look at your vertex, is, let me see if I can change this view. Okay, let's look at that full screen. Okay, maximum height, we're going to actually look at our vertex, and it's actually going to be the y value there. Okay, so this is the time here, this is the height here. So we are going to say that our maximum height is 16 feet. Okay. How long does it take to reach that height? Okay, right here it takes us 1 second to get up to 16 feet. So it takes 1 second there. Okay, how long is the ball in the air? Okay, starts on the ground at 0, goes up to 16 feet at 1 second, and then drops back to the ground at 2 seconds. So we're looking at the x-intercept there. And it's the second one, so 2 seconds. Okay, the y-intercept is right here at 0, 0. That represents the starting height. Okay, and then when we talked about key features, we said that the domain is always all real numbers. Now when we look at applications, we don't have that. The reason we don't have that is because, in this case, I'm looking at time. Time can't be negative, and The ball hits the ground at 2 seconds. It can't go below the ground. So my time, or my domain, actually goes from 1 to 2. Sorry, from 0 to 2. So the reasonable domain is x goes from 0 to 2. Okay, another way we write this in algebra is using an interval. It looks kind of like a point. This tells me I'm going from 0 to 2 as well. We'll talk about that more in Algebra 2. I would prefer the inequality for Algebra 1. Okay, so there's one example. Let's go ahead and do the next graph. So the next one, as Molly dives into her pool, her height in feet above the water can be modeled by the function f of x equals negative 16x squared, A, plus 16x plus 12. I'm going to do the opposite of b over 2a. So I actually end up getting 16 over, forgot to change my sign, negative 16 over negative 32. So negative 16 over negative 32 is negative 0.5. So if we're going to go ahead and make our table, 0.5 is going to go first. Let's go ahead and plug that in. So I'm going to do negative 16 times 0.5 squared plus 16 times 0.5 plus 12. So when I plug that in, I get Okay, so at 0.5 seconds, my height is 16. That's my axis of symmetry there, right through the middle. Okay, now, I don't want you to use decimals for the rest of them because it's easier to use whole numbers. So I'm going to try 1 and 2 and plug those in and see what happens. So if I plug in 1, I get negative 16 times 1 squared plus 16 times 1 plus 12. So when I plug this in my calculator, I get 12 for an answer. So I have the point 1, 12 here. And then when I plug in 2, we actually get a negative. So negative 16 times 4 plus 16 times 2 plus 12 gives us negative 20. Okay, so remember, we can't hit a negative because we're looking at a real life situation. I am going to reflect this to the other side. So I start at 12, go up to 16, back to 12, and then I keep going till I hit the water. Okay, so there's our graph. Okay, so now that we have our graph, let's answer the questions. Maximum height here, again, ended up being 16 feet. That's just coincidence. It doesn't always work out that way. So maximum height is right here at 16 feet. It took us a half of a second to reach there. At what time does she hit the water? I don't know, somewhere between 1 and 2 seconds. We know it's not 2 because 2 is negative 20. So I'm going to say about 1.5 seconds. Would be close enough. We're just approximating. The y-intercept is 12, and this is her starting height. Okay. And then reasonable domain, we start at 0 because we don't have any negative, and we go until she hits the water. So we're going to go from 0 to about that 1.5. Yours might be slightly different if you approximate it differently, but that's the answer. Okay, so we do not have guided practice today. All you need to do is make sure you understand this. Let us know when you're ready. We'll give you your homework and help you out if you have any questions. Good luck. Ask if you need help, and get this done for tomorrow. Have a great day.